These programs are distributed under a Creative Commons Attribution Non-Commercial No Derivatives license. You may copy and distribute these programs free of charge. You may not sell them, and you may not alter them. These programs are part of a study examining the value of podcasting as a medium for medical education. If this is the first time you are viewing a program in this optic series, send an email to jyoungmd@gmail.com with your name, position, institution, and city, state, or province, and country. Thanks, and enjoy the podcasts. This is not even really a full lecture. It's a discussion of one little topic, but I couldn't see where it fit in with anything else, so we're just going to do it separately. This is the SRK formula for the calculation of intraocular lens power. It is not a formula that is employed anymore, but is a good yardstick for us to examine what happens when we make errors in different parts of the formula. So the formula is given as intraocular lens power is equal to A, which is the A constant, which is something that the manufacturer gives you, minus 2.5 times the axial length of the eye in millimeters, minus 0.9 times the average keratometry. Now, we can clearly see what's going to happen when we get some of these factors wrong. By how much will the intraocular lens power be off if we are a millimeter off in our axial length? And the answer is that the IOL power is going to be off by 2.5 diopters. Similarly, if we're off by our keratometry, that is going to create an almost equal error with the intraocular lens power. Intraocular lens power is, of course, not the same thing as spectacle plane power, and an error of the intraocular lens power is not going to translate one-to-one with an error at the spectacle plane. And this is, of course, true because there is a correction for vertex distance between spectacles and intraocular lenses, just as there are with spectacles and contact lenses, even more so because the vertex distance is even greater. The change in vertex distance is even greater. So, but roughly, a millimeter in axial length is going to be about a quarter diopter of the spectacle manifest. Or you'll hear people say things like 1 millimeter in axial length is about 3 diopters in error. The thing is that this is, of course, highly dependent on the particular patient's eye and the particular axial length. And these numbers are just generalizations. That an error of between 1.25 and 1.5 diopters at the IOL plane will be about 1 diopter at the spectacle plane, and that a diopter off of keratometry will be in the range of a diopter in the spectacle plane. But again, take all these numbers with a grain of salt. Thanks.